Hi everyone, welcome to this next video. So in this one we're going to talk about transformations. We're going to go through all four of them. We're going to talk about which ones would be on higher, which ones would be on foundation, and how to do them. So let's jump straight in. So first one, enlargement. Okay, so first of all, the way I remember the four transformations is if you remember ERT, E-R-R-T, so enlargement, rotation, reflection, and translation. They are your four transformations that you need to be aware of. Now with enlargement, it's going to make a shape bigger, but it can also make a shape smaller, and it's really important that you understand that if a shape has got smaller, it can also be enlargement. Now, if a shape gets bigger, the scale factor will be an integer, a whole number. So it could be 2, it could be 3, it could be 4. It could also be a negative, so it could be -2, -3, -4, etc. And we'll talk about negative enlargement a bit later on. Negative enlargement would only be on higher. Now, if we're talking about a shape getting smaller, you can talk about it being a scale factor of a half, a third, a quarter, and that could also be negative as well. It could be something like -1/5. But with a scale factor that's a fraction, it will actually make a shape smaller. From here, the other thing you need to think about a scale factor, which we just touched on there. So you're thinking about how many times you multiply that shape to get it bigger, or how many times you divide that shape to get it smaller. That is what you need to think about. So a scale factor, and you must always have a center of enlargement as well. Okay, so when we're talking about enlargement, you must have a scale factor and a center of enlargement. Next one, let's talk about rotation. So with rotation, we're going to be talking about the number of degrees that the shape moves, and that will be 90 or 180. Now the reason it's going to be 90 or 180 is because if you think about a circle, if I start at this point here, if I rotate around that way, that's 90 degrees clockwise. If I then carried on and got to this point here, that would be 180 degrees. Now if you go 180 degrees clockwise, so if I go this way 180 degrees, or I go this way 180 degrees, I end up in the same place. Okay, now the reason, as I say, that it's only really going to be 90 or 180 is because if I go 90 degrees this way, that would be the same as going 270 degrees that way. So 270 degrees would never really be used. Okay. So then the next thing you need to think about is the direction. Okay. So with rotation, you've got to talk about number of degrees, you've got to talk about direction, and then we also need a center of rotation. So where does it rotate from? And we'll talk about that a little bit in a minute. So they're the three things you have to think about: number of degrees, direction, and center of rotation. For enlargement, there's two things you need to talk about: scale factor and center. So let's look at reflection now. With reflection, you're going to be talking about a mirror line. So this basically is, if I have a graph like this and I had a shape here and it goes down here, I'm thinking about where is that actually reflected? Where would my line be? So for example, roughly speaking, I'd have a line that goes along there. Where would my mirror go to reflect that shape? Now, never ever say the word flipped. So don't talk about the shape being flipped. Okay, it is either reflected or reflection is what you're talking about. Okay, so yes, it does flip the shape when you put it in a mirror and in a mirror line, but never say the word flipped. Okay, and then the last one we're talking about is translation. So translation basically shifts the shape. So if I had a shape like this here, and then it ended up being down here, you're talking about how many spaces it moves left or right, and how many spaces down or up it moves. Now with this, you must have a vector. And a vector looks like this. If it's positive, it will move the shape right. If it's negative, it moves the shape left. That's the top value. So the X value tells you right or left. And on the bottom, if it's positive, it will move the shape up. And if it's negative, it will move the shape down. Okay. Now, if I look at that in the example I just did, from here to here, I go 1, 2, 3, 4. So that's 4 left. So it'd be -4. And then 1, 2 down. So that would be -2. So that would be the vector for that movement from A to B. And we'll talk about that a little bit more in a second. Okay, so they're your key pieces of information. Worth having those on a flashcard. Just things to understand. Remembering that enlargement, scale factor, center. Rotation, number of degrees, direction, and a center. So enlargement and rotation, you need a center that they're enlarging and rotating from. With reflection, you just need a mirror line. And translation, you need a vector. Okay, so really important you understand those. So let's jump straight in and look at rotation first of all. This is a little bit difficult to do on an iPad, but I'll try my best to explain what is happening. Any question with transformations, you'll have two types. You'll have to do it, so completing a rotation, and then you'd have to describe a rotation as well. So we'll talk through this and how this works. So it says here, rotate shape A 90 degrees clockwise about the point 1, 1. First thing I'm going to do is go to 1, 1 and put a cross there. That is the point that I'm rotating from. In an exam, you have a piece of tracing paper. So what you then do is you put your tracing paper over the top, and then with your tracing paper, draw around that shape and put a point on the corner there. Now, it's going to be a little bit harder for me to do. So imagine I've got a piece of tracing paper over the top, and I've got that there and that there. And then what I'm going to do is just imagine that I'm now going to rotate it. So you put your pencil on the cross, and then you turn your shape 90 degrees clockwise, which means it's going to the right. Clockwise is to the right, and it's going to spin in this direction. Now, what you're trying to do is make sure that that cross stays on that point there. Okay, that doesn't change. So if you can see now that that shape has moved, and this point here is at a right angle to where the original point was. So what I'm going to do is I'm just going to show you exactly where it was before. That's where it was before, and this is where it ended up when I did that rotation. So you can see here that the reason I know that's 90 degrees is because that line there to that line there now makes a 90-degree angle, okay? And I've moved it clockwise, which is in this direction. It follows, if you've got a watch, it follows the second hand round. Obviously, if you go that way, that's anti-clockwise, okay? So that is now my shape B. That is where that shape would be. I'm going to make that a little bit tidier. It would actually move to that point there. So just remember, redraw the shape on your piece of tracing paper, put your pencil on that point, hold it down, and then spin it round until you get to the location that you need to get it to. Now, if it said something like 180 degrees, so here's what I would do. I'd spin it. That's my 90-degree spin, and then I'd keep my point on that corner to there, and then I'd spin it round to that point there, which would be my 180 degrees that it has moved, okay? So just double check that if I go back again. So that's my 90-degree backwards, and then that's another 90, so that'd be 180 degrees, okay? So that's how you do 180 degrees. Now, when you do 180 degrees, it doesn't matter which way you go. So if I go 180 degrees that anti-clockwise, it's the same as going 180 degrees clockwise, okay? So let's look at what happens when we're talking about describing a rotation now. So this question says here, describe the single transformation that maps A to B. So whenever you see the word transformation, you've got to pick which one it's going to be. It's going to be enlargement, rotation, reflection, or translation. So in this case, we are talking about rotation. So I'd actually write the word rotation. Okay, do not write flipped, do not write spins. You have to use the word rotation. We then need to figure out how many degrees that is. Now, what I can see here is this line is here on A, and this line's here on B. So that would be 90 degrees, where it would create a right angle, and then it'd come back round again. So I know it's going to be 180 degrees. Now I need to just figure out which way it's gone. If I go clockwise, if I go anti-clockwise, it doesn't matter because it's 180 degrees, so I can leave a direction. And now I need to figure out where it rotates from. Best way to do this, with your tracing paper again, so you get your tracing paper, put it over the shape like that, and then you redraw your shape A over. So there's my shape A redrawn. And then what you do is you pick a point. So I'm going to just pick a random point there and see what happens. If I was to choose this point and rotate this shape 180 degrees, so if I spin it first of all to there, that would be 90 degrees. And then I'm going to spin it again to there, that's 180 degrees. So 180 degrees clockwise means I'm not quite in the right place. So I'm going to have to go back again and understand that it can't be this point. So that can't be my center enlargement, so I rub out. So now we're going to choose another point. Now what I'm going to do is I'm going to choose this point here. So from that blue point, I then, with my tracing paper, draw over it. I spin it 90 degrees, first of all. It takes me to there, okay? And then I spin it one more time again, keeping that cross where it needs to be. And I can see that actually when I do that, I end up going on top of shape B. So I'll do that in reverse so you can see. So if my pencil is on that cross, if I spin it 90 degrees anti-clockwise, I'm going backwards that way and then backwards to the top there, right? So when I actually do the full 180 degrees turn from that point where I'm keeping my cross on the corner there, keeping it there, it spins round and ends up in the same location. So now I've found that point, this becomes my center of rotation. So you can say it's rotation 180 degrees, center, the coordinates of that are -1, 2. Just remember, so I've done the scale of each square here represents 1. You go -1 and then up 2. So you're using the x value first for your coordinate. Okay, so that's how you would complete rotation. That's how you would describe rotation. Okay, let's now move on to looking at reflection, what we do for reflection and how reflection would work. Okay, so we're going to do completing reflection first of all and then describing reflection, and we'll go through the processes for both. So in this first one, it says here, reflect shape A in the line y equals 2. Okay, the line y equals 2 means it crosses the y-axis at 2. Now, again, I'm using a similar scale along here. So each square will represent 1. So that's 1, 2, 3, 4, 5. And here it's 1, 2, 3, 4, 5. So your y-axis being this one, it crosses the y-axis at 2. So you draw your mirror line on. This is the line y equals 2. Crosses the y-axis at 2. So then what I need to do is just figure out how do I go from shape A. If I was to put a mirror along here, where does shape A go? And it's going to end up being down in this direction. So this point here is 1 square away from the mirror line. So then I bring it down here. This square here, this corner here, sorry, is 1 square away from the mirror line. So I bring it down here. And then the top point is 1, 2, 3. So I go 1, 2, 3 down. And it ends up down there. And then I redraw that like that. And that is your shape now reflected in the line of y equals 2. Okay, let's label that B, so we know we've done that first one. Okay, now let's look at what happens if I have to do it in the line x equals 1. So it crosses the x-axis at 1. Now your x-axis being this one, so my mirror line now goes down here. So from here, I'm then looking at that corner. It's 2 squares across from there to the mirror line. So I go 2 squares the other way. So that corner ends up being there. Do the same here. 1, 2, 3, 4, 5, 6. So from the mirror line, 1, 2, 3, 4, 5, 6. So it goes 1, 2, 3, 4, 5. Goes there. And then this top point is 1, 2, 3, 4 away from the mirror line. So 1, 2, 3, 4 away from the mirror line. And then I redraw my shape there. Let's call that C. Okay, so that's how I would do those. Now, the only other one is if you have this type of mirror line. Let's just rub all this out now so you can see exactly what's going to happen a little bit clearer for you. So getting rid of all those lines. Okay, now the line y equals x is a diagonal line. Okay, if you go back to equations of lines, it tells you that the gradient is 1 and there isn't a 0 intercept, which means what happens is it's going to go through every corner of your graph. So this is the space that your line will end up going. This is the line y equals x. Okay, now if it was y equals minus x, it would go the opposite way. So this line here would be y equals minus x, but we're not talking about that for now, so we can get rid of that line. We're talking about y equals x. Now to do a diagonal reflection, all you do, exactly the same thing. So I pick a point and then you go diagonally to the mirror line this time. So 1, 2 squares away. So then I go 1, 2 squares away. And that point ends up being there. So again, 1, 2, 1, 2. Pick a next point, 1, 2, 3, 4 squares. So you go 1, 2, 3, 4. And it ends up bringing you down here. And then the last one is the top point, which is 1, 2, 3, 4 squares diagonally. So from this point, 1, 2, 3, 4, put your point there. and that is your new shape drawn. Now what you notice is when a shape is reflected in a diagonal mirror line, it kind of rotates it a little bit as well. Okay, so that's how you complete reflection. That's how you reflect it in a line that's y equals, so y equals crosses the y-axis, x equals x-axis, and y equals x diagonal. Okay, so let's look at what happens if you're describing it now. So here we've got two shapes. Okay, we've got shape A and shape B. It is clear that that is a reflection, but you could also say this is a translation because the shape has just moved across, but we're talking about reflection, so we're just going to look at describing it with a reflection. So we would use the word, because it says describe the single transformation, we need to use the word reflection. Okay, we're not using the word flipped or anything like that. We're saying the word reflection. And then we need to say in the mirror line, or you could just say in the line, and you need to figure out where it's been reflected from. So if I pick that point and that point, you can see 1, 2, 3, 4, there's a difference of 4. So you go in the middle. So in the middle of those 2 points is there. If you wanted to double check it, let's pick another point. That point there, 1, 2, 3, 4, 5, 6, 7, 8, difference of 8. So you go in the middle, 1, 2, 3, 4, and it's along the same line. So I can very clearly see that this is where my mirror line would be. From there, you just need to find the equation of that line. Well, again, if we use the same scale here, that's 0, 1, 2, 3, 4, 5. This would be 0, minus 1. So it's a reflection in the mirror line. We know there's going to be a minus 1 involved, but which axis does that green line cross? That's my y-axis, that's my x-axis. It crosses the x-axis at minus 1. So your answer there would be reflection in the mirror line, x equals minus 1. Okay? So that's how you complete reflection, and then that's how you describe reflection, just making sure that you're always talking about the mirror line when you're describing it. So moving on now to translation, this is what we have got. So let's do, again, we'll start with completing. We're going to complete translation first. It says translate shape P by the vector 3 minus 2. So to do this, we're moving it 3 right, and that's going to be 2 down. All you do, pick a point, you go 3 right with that point, 1, 2, 3, and then you go 2 down. So that black point now moves to there. If you wanted to, you could do that for every point. So 1, 2, 3, 1, 2. Pick the next point. Go 1, 2, 3, 1, 2. And then the last point, blue one, 1, 2, 3, 1, 2. That's where it moves to. If you didn't want to do it for every single point, as long as you get one in the right place, you can then redraw the shape in exactly the same size once you've got one of the points in the right place. So if I know that that black point was the first point that I did, I know it's 2 wide and 4 down, so I go 2 wide and 4 down as I do it. Let's call that shape Q. It might tell you what to do. It then says translate your new shape minus 5 minus 3. Well, my new shape is Q, so let's pick this blue point in the bottom corner. It says minus 5, so that's left 5, and minus 3, that's down 3. So you go 1, 2, 3, 4, 5. 1, 2, 3. That is now my new blue point. Okay, and again, what you could do is you could just redraw it from there if you wanted to, or if you want to pick each point again, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and then 1, 2, 3. You could do that, or as I say, you can just redraw it from this point if you're happy to. I'm going to redraw it now because I know 1, 2, 3, 4. It's 4 high and 2 wide. Let's call that R. Okay, so that's where you'd move it to. So sometimes it'll ask you to rotate the original shape, ask you to translate the original shape, but this one's actually telling us to translate the new shape. The last thing to talk about actually is then P to R. So P to R is a translation, and actually what happens is now it goes 1, 2, 1, 2, 3, 4, 5. So it's gone 2 left and 5 down. So I'd write that as minus 2, minus 5. So from there to there, 1, 2, 1, 2, 3, 4, 5. This is called a resultant vector. Now that is a result of 2 movements. First one, second one, and then the actual resulted movement is from there to there. Now if you actually look at the 2 vectors we were given, 3 minus 2 and minus 5 minus 3, okay, I can actually end up getting those numbers. if I add those vectors together, 3 plus minus 5 gives me minus 2, and then minus 2 plus minus 3 is minus 5. So when you add two vectors together, if you've got movement taking place twice, it will give you what we call the resultant vector, which is the final movement from the original shape to your last shape drawn. Okay, so that's just something to be aware of as well. Okay, going to get rid of that, just to create a bit more space. Okay, let's look at now how we would describe this. So it says here, describe the single transformation that maps A to B. Right, so for me to go from A to B, I know I'm going to say translation, because the shape is exactly the same, but it's just been moved. Okay, so translation is what I will be using. It's not got bigger, it's not got smaller, it's not rotated in any direction, and it's not been reflected. So therefore I know it's going to be translation. Pick a point, so I'm going to pick this bottom corner, go to this bottom corner. For me to do that, I go 1, 2, 3, 4, 5, 6 left. So 6 left means I'm going to go minus 6. 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6, 7 down, minus 7. So you would say translation by the vector minus 6, minus 7. If it asked you to do B to A, well, pick that point, get to that point, 1, 2, 3, 4, 5, 6. So it'd be positive 6, and then 1, 2, 3, 4, 5, 6, 7, positive 7. One thing to be aware of is just make sure you are choosing the same point to the same point, because if I choose that point there and then I try and get to that point there, that's wrong. Okay, if I'm choosing that point in the top corner of the B, I've got to go to that top corner of A and vice versa. So make sure the point you choose is the corresponding point. Okay, last one we're going to talk about now is enlargement, which is definitely a little bit more complicated, and there's a lot of stuff involved in this one that we need to go through. So jumping in then, let's have a little look at what we're doing for enlargement. So the first one here, it says large shape A by scale factor 2. So that means everything's going to be multiplied by 2, and then we've got the centre as minus 4, minus 5. So let's put the centre in first of all. So 1, 2, 3, 4, 1, 2, 3, 4, 5. That's my centre of enlargement. Okay, so that is the point. So that is the point where I'm going to be enlarging this shape from. So to do this, what you do is you pick a corner. So I'm going to pick this bottom corner here. For me to go from the centre of enlargement to that point, I go 1 right and 2 up. So you go 1 right and 2 up. What I then do is I take that information and I times it by 2 because my scale factor is 2. So I now go 2 right and 4 up. I go back to this point, so you're always going back to the centre of enlargement, and I go 1, 2 right, and 1, 2, 3, 4 up. So that now is going to be where I put that purple point. So that purple point has now moved to that point there. So it was there, it's now going to go there. What I then do is I go from this point and I pick the next point. So let's pick this bottom right hand corner. So I go 1, 2, 3 right and 2 up. So let's get rid of that. I'm going 3 right and 2 up, times all that by 2. I go 6 right and 4 up. So I go back to this point. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So that point there. So that point there is where I then do that blue point. Now you can double check that's correct because the bottom of this triangle was 2. Now if I times 2 by 2, I end up with 4. So this is going to be the bottom of my triangle, and that is 1, 2, 3, 4 squares along, which is twice 2. So that works. Let's choose the last point now. That's my orange point. So I'm going from the red point 1, 2, 3 right. So that's 3 right. And then I'm going 1, 2, 3, 4 up. So times that by 2, I go 6 right and 8 up. So from the, always go back to that centre of enlargement. You go 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6, 7, 8. And that will be my new orange point there. Again, you can double check. That height there is 2. So I need to double it. 1, 2, 3, 4. So that's correct. So therefore, that is now your triangle. So you redraw it like this. And that has been enlarged by scale factor 2. Now to double check you are correct, what you can then do is if you get a ruler and you join all your points together, so the purple to purple, the blue to blue, and the orange to orange, they should all meet at that point where the centre of enlargement is. Okay, so just remember, you're going from the center of enlargement to each point, count how many squares right or left you go, and then up or down. And then from that, double it because the scale factor is 2. If the scale factor was 3, I'd times it all by 3. Okay, right, let's look at what happens with fractional. So the process is the same. The center is going to be 4, 7. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. That is my center of enlargement. And I do the same process. So let's pick the top corner. How do I go from this to this? 1, 2 left and 2 down. So it's 2 left and 2 down. Now, because my scale factor is a half, I actually divide that by 2. So I go 1 left and 1 down. And again, we're going to this point. So 1 left and 1 down. So that becomes the top of my triangle. Now, let's pick this bottom left-hand corner. So 1, 2, 3 left. 1, 2, 3, 4, 5, 6. So it's 3 left and 6 down. So I divide all of that by 2 because the scale factor is a half, which becomes 1.5 and 3. So I go 1.5 left and 3 down. You can have decimals in this. So from here, 1.5 left, and then 1, 2, 3 down, which means this purple point now ends up there. And then the final one, the bottom corner, I'm sure you can probably figure out where it has to go, but let's just go through the process. 1 left, 1, 2, 3, 4, 5, 6. So 1 left and 6 down becomes, so we're dividing by 2, which is the same as timesing by a half, becomes 0.5 left and 3 down. So from here, half left and 1, 2, 3 down. That ends up being at that point there. And then using your pen and your ruler, join it up. Let's call that shape B. And that has been enlarged by a scale factor a half. So it's got half as big. Let's double check again. Put pink to pink, blue to blue, purple to purple. They all join up at that point. So I know I'm correct. Okay, so that's how you can do it with a fractional. If that was a quarter, you'd divide by 4. If it was a third, divide by 3. If it was a fifth, divide by 5. Okay. Right, this bit here is only on higher, so this is you only need to worry about this if you are doing the higher paper. And the concept's similar, but just a little bit different in how we move away from the centre of enlargement. So same thing, 0 minus 3 is my centre of enlargement. So let's put that on first of all. That point there is my centre of enlargement. I'm still going to pick a point, and what I'm going to do with this point is count how many squares it goes to the cross. So 1, 2 right, and 2 up. So I go 2 right and 2 up. Now what I'm going to do to help me with this and figure out where to put the point is I'm going to draw a line that goes through the centre of enlargement. Okay, so what I know is that this red point has to be somewhere along that line. Because my scale factor is minus 2, I times all this by 2. So therefore I go 4 right and 4 up. Okay, you go back to your centre of enlargement. So from here to here, I went 2 right, 2 up, and now I go 4 right. So 1, 2, 3, 4, and 4 up. 1, 2, 3, 4. Now, that is the point where it needs to be. And actually, if I then draw that line a little bit better, you can see that it goes through that point. Okay, so drawing that line just tells you where it should be along that line, and it helps you to make sure that you're in the right place. Let's see what happens with the next one. So we'll go through the process again. So count how many squares it goes. So it's 1, 2, 3, 4 right, and then it's 1, 2 up. Times all that by 2, I get 8 right, and I get 4 up. So you go back to your centre of enlargement. I'm going to draw a line diagonally through that point. Just make that line a bit better. So I know my point is going to fit somewhere along that line. Okay, so it was, now I've got to go 8 right. So from here, I go 1, 2, 3, 4, 5, 6, 7, 8. And then 4 up, 1, 2, 3, 4. And you can see that green point fits perfectly there. Okay. Right, so let's now get this last point in. So this last point being this pink one at the top. We know for me to go from the pink point to the centre of enlargement, I'm going 1, 2, 3 right and 1 down. So 3 right, 1 down. And again, what I'm going to do is draw my line all the way through. So I know it's got to end up along that line somewhere. So instead of going 3 right and 1 down, I'm going to times that by my scale factor, which is 2. So 6 right and 2 down. So you're going back to this point, 1, 2, 3, 4, 5, 6 right, 2 down. And you can see is at that point there. Okay, so we've got all our points in. We're going to then join the lines up, and you can see what has happened here is that the shape is actually flipped upside down. So with a negative scale factor, the shape will get bigger or smaller, but it will also flip. Let's call that shape B. Then to just double check I've got everything in the right place, you can join each point to each point, double check it goes through the middle, and it does. Okay, so that's how you just do your negative straight away. Now let's look at what would happen is if it's negative and a fractional scale factor. Okay, so same thing, we're going to plot our centre of enlargement first of all. So that's at 1, 1, which is this point here. So this is my centre of enlargement. That's the point I'm going to be referring to. Let's choose the bottom corner of the triangle to start with. So for me to go from there to the centre, I go 1, 2, 3 right. Now there's no up or down in this. So instead of going 3 right, because my scale factor is a fraction, instead of timesing by a third, you could also then divide by 3. So I'm just going to divide that by 3. So instead of going 3 right, I'm going to go 1 right. And again, remembering you go back to this. So now I go 1 right, and I'm going to put my point there. So that red point now goes there. If you wanted to draw your line again, you could draw your line, and then you can see it sits along that line, but not really necessary when it's going to sit along that line. Let's choose this green corner. So again, it would sit along this line somewhere, which is pretty easy to figure out. Let's now get the point right. So 1, 2, 3, 4, 5. I go 6 right, and because my scale factor is a third, I divide that by 3, which gives me 2 right. So I go back to my red cross and go 2 right, and then get that green point in place. And then we follow the process again. You can probably figure out from here where it would go, because you could argue the fact that 1, 2, 3, 4, 5, that's 6 high. 6 divided by 3 would give you 2. So this height would actually be 2, but let's just get the point in the right place. I'm going to draw a line through that from that blue point, so I know where it roughly should be. And I'm counting 1, 2, 3 right. And then from 1, 2, 3 right, 1, 2, 3, 4, 5, 6 down. So instead of being 3 right and 6 down, I divide that by 3. It becomes 1 right and 2 down. Go back to your centre of enlargement, go 1 right, 2 down, and you can see it does indeed end up in that place that we were talking about. Let's rub out that line that we used, and then we can join those 3 points together, because we know that is where my shape would be. Let's call that shape B. Okay, so that's how you actually do negative enlargement. That would only be on higher. That would not come up on foundation, remember. So that's only something you need to worry about if you are sitting in a higher paper. Right, last bit we're going to look at is we're going to talk about how we describe enlargement. Okay, so this is the last part of the video. Stay with me. We're going to go through how we actually describe enlargement if it was to come up in an exam. Okay, so the question will say, describe the single transformation that takes A to B or B to A. What we need to do is we need to look at, first of all, what's happening. We're going A to B. So we're going from this shape to this shape. So you need to think to yourself, what's happening for me to go from A to B? Has the shape rotated? No. Has it reflected? No. Has it got bigger? Yes. So therefore, because it's got bigger, you need to then say, you need to write the word enlargement. Okay? So enlargement is the first thing you'll put down. It's enlargement. Now what we need is a scale factor, and we need a centre. So let's get the scale factor sorted first of all. That side there is 2 across. And this side here is 1, 2, 3, 4, 5, 6. Well, how do I go from 2 to 6? I times by 3. So your scale factor will be 3. Okay, but now the last thing you need to find is the centre. Where does it actually enlarge from? And in order to do that, all you do, take your ruler, take your pencil, and join each corner to each corner. Follow your points through, extend them out a little bit if you need to, and then where they meet, which is this point here, is your centre of enlargement. So if I now, using the same scale, that's 1, 2, 3, 4, 5, that's -5. And then count down 1, 2, 3, 4, 5. So my centre would be -5, -5. So it's effectively the same as what we just done, but working backwards. Okay. So drawing those lines will give you a centre. Find your scale factor by matching up a side, and always write the word enlargement. So let's look at the next one here. Got to be really careful here because it says B to A. So we're going from here to here, which means the shape is actually going to get smaller. Okay, if the shape's getting smaller, it will be a fractional scale factor. Okay, so let's just double check. First of all, we're going to write the word enlargement. So we write the word enlargement. We say the scale factor. So we can say enlargement by a scale factor, and we're going to work that out. And then your center, we're going to work that out. Okay. So we're going from B, which is 2 wide there, and A is 1 wide there. How do I go from 2 to 1? I divide by 2. If you're dividing by 2, that is the same as timesing by a half. So your scale factor is a half. Whatever you're dividing by effectively will be your fraction. Just put it as 1 over that if you're ever not sure. Last bit then, find your center of enlargement. Join that corner to that corner, bottom corner to bottom corner, bottom corner to bottom corner, and top corner, top corner to top corner. And you can see that they all meet at that point there. So for me to go from shape B to shape A, my center enlargement there is 1, 2, 3, 4, 5, 6, minus 6. 1, 2, 3, 4, minus 4. Okay, so that would be your answer for B to A. Just being careful you don't put a scale factor of 2 there, or minus 2 or anything like that. It is a scale factor of a half because the shape's got smaller. As soon as the shape gets smaller, fractional scale factor. Okay, last bit then, let's have a little look at how we then describe negative enlargement. So again, only on higher. So looking at these questions, instead of you actually making the enlargement happen, you are describing what's happening. So let's quickly go through these. We know it's going to be an enlargement. So we're going to write the word enlargement. So it's an enlargement by a scale factor, something, and then center something else. Now remember, the reason that you know this is going to be an enlargement is because the shape has flipped, but it's changed size. So if a shape had flipped, you could argue that it's some form of a rotation. But however, because the shape from A to B has flipped around, it's rotated round, but it's also bigger, it has to be a negative enlargement. Okay, so it's enlargement. Now let's find the scale factor. We're going from A to B, so I'm double checking that. It's that one to that one, not that one to that one. 2 wide at the bottom there. And this one is 4 wide. How do I go from 2 to 4? Well, I times by 2, but because it's flipped, it's going to be a minus 2. And then to find your center, here's what you do. You basically pick the corresponding corners. So that corner is that one. That corner is that one. You can see straight away they cross at a point. Confirm it. They all meet at that point there. So my center enlargement there would be 1 minus 1. Okay, so it's enlargement by scale factor minus 2, center 1 minus 1. Final one then, you could have a little look at this and do it yourself. Double check A to B. Yep, we're getting bigger. So you'd write the word enlargement. Make sure you always write which transformation it is. Enlargement by a scale factor. Need to find that. And then your center, we need to find that. So if you did want to have a go at doing it yourself, you could draw it out on a piece of paper and have a go yourself. If not, I'm going to go through it. So the scale factor, that's 2 wide. That's 4 wide. So it must be minus 2 again. And then all we're going to do, join that top point to that top point. Now you need to be careful here. This bottom corner doesn't go to this one. It goes to this one. Because remember, it's the opposite. It's flipping. Then you're going, this corner here would go to this corner here. And then this corner here would go to this corner here. So slightly more complicated shape. But you can see they all meet at this point. So your center would be 1 minus 3. Okay? So 1, 1, 2, 3. So we've gone through a lot of stuff in this video. We've gone through all the 4 transformations: enlargement, rotation, reflection, and translation. Just remember, they really hurt. I suggest what you do is go back, watch through certain parts of the video that you're not sure on, and it will help you with revision, and also make flashcards on them so you get the key pieces of information down. Remember, all of them can come up on foundation and higher, except for negative enlargement. Negative enlargement would just be on higher. Okay, hope you found it useful. Hope it helped you. I'll see you all in the next video.